Today we are working on chapter 10, as you know, correlation and regression. We are going to look at some examples related to correlation and regression, which will help you in Math 135. So we are going to begin with the example. So here is our first example. You have seen that in correlation and regression, we work on equation of line, which is called the line of best fit. So here we have a basic equation of a straight line. You can see here, write the equation of the line in the slope-intercept form. When we say slope-intercept form, that is the equation in the form y equal to mx plus b. And m is the slope, okay? M is the slope of the line, and b is the y-intercept. So once you have the slope and the y-intercept, we can write the equation in this form, y equal to mx plus b. And after we have the equation, we are also asked to sketch the graph for each of these. So for the first one, you can see the slope is 8 over 11. So in place of m, we'll write 8 over 11. And then b is 3. So in place of b, we'll write 3. So the equation will be y equal to 8 over 11 is the slope times x plus 3. That is the equation of the first line because the slope is 8 over 11 and the y-intercept is 3. And we are also asked to sketch the graph. We are not making that perfect graph, but we are making a sketch here. So in order to sketch the graph, what I have done here is in this graphing grid here, I'm counting by 2. I have the scale there, so I'm counting by 2. Y-intercept is 3. So this is your 2. 3 should be in the middle. So that is your y-intercept. You mark the y-intercept. And then after you mark the y-intercept, your slope is 8 over 11, meaning you go up 8 units and then 11 units on this side. So when you go 8 units up, you count by 2. So when you go 8 units up, you can see that it will be, so see, rise is 8. So from here, you are going 8 units up. So this is 2, 4, 6, 8, because we are counting by 2. So 2, 4, 6, 8. That's your 8. You don't have to mark that point. And then you are going 11 units horizontally. From here, you are going 11 units. So from here, you will go 11 units. So let's count 11. You're counting by 2. So 2, 4, 6, 8, 10, 11 should be somewhere there. Do you see the point there?
Is this the lab worksheet for chapter 5 of the
Yes. Do you have something else in the Dropbox?
I don't have like these examples. I have different
Okay.
questions.
Okay. What I'm going to do is at the end of this video, I'm going to look at it again and re-upload
Shouldn't
it.
it be the chapter for 10?
Yes, this is chapter 10. That's right.
Okay.
Okay. If you have downloaded that correctly, that's fine. If not, I'm going to look at the Dropbox number 5 later on and update this worksheet. Okay.
Okay, thank you.
No problem. So we got this point. So you can see we started with the y-intercept. We go up 8 units and then 11 unit across because the slope is rise over run. So we rise 8 units and run 11 units. So we get that point. Now we draw this straight line connecting these 2 points. So that will be the equation of this straight line there. So let's try that. Straight line connecting these 2 points. So you can extend this all the way to the end of the graph like that. Just like that. That is your first equation. So I'm going to mark that A so it is easy to read later on. So that's your first equation here. Now let's look at the second one. The slope is 9 over 11. So your equation will be y equal to 9 over 11x. And then the y-intercept is 1 over 13 plus 1 over 13. If you look at the value of 1 over 13, it is close to 0. So the y-intercept is very close to origin. So this should be the y-intercept. Let me use different color this time. So this should be the y-intercept, which is very close to 0. Then You're going 9 units up. You're counting by 2. So 2, 4, 6, 8, then 9. So 2, 4, 6, 8, and then 9 should be somewhere there. If you can see, it should be somewhere there. Then we are going 11 units horizontally. So you are moving 11 units from here. Again, you are counting by 2. So you count like 2, 4, 6, 8, 10. So 11 should be somewhere there.
It's
Okay.
17.
Oh, it's 17.
Yeah.
Thank you. You
Yep.
are good. 17. So we are going a little farther then. So from here, 2, 4, 6, 8, 10, 12, 14, 16, 17 should be there, right? That's your 17. You can count one more time, 2, 4, 6, 8, 10, 12, 14, 16, 17. Yes, that is the point. Okay, so that is the point. And here we are at the first point. Now you can take a straight line, any straight A's that you have, and then you can draw the line connecting those 2 points like that. And if you want, you can extend it throughout the graph paper or throughout the grid. It will look like that. So that is your second graph, B. That's B. Let's look at C. In C, you can see the slope is -1/2. Both lines have positive slope in A and B. So when you go from left to right, they are going up. But in the third one, the slope is negative. That means the line will come down like this. When you go from left to right, the line will go down. So slope is -1/2. So we can write that as y equal to -1/2x. And the y-intercept is, because it passes through 0, 3, x is 0. When x is 0, this is your y-intercept. So y-intercept is 3 plus 3, because for y-intercept, x value is 0. So your y-intercept is 3, which was this point up here. That is 3. And then you can see that we have -1/2. So you go -1 unit down and 2 unit horizontally. That's the meaning. So when you go -1 unit down and 2 units horizontally, this is your 3. So 1 unit down will be somewhere here in the middle. And then you are going 2 units on the other side. So the point is right there. So that is the point. Now what you'll do is you'll get the straight A's again, and then draw the line. Let me use this color for that. Okay, so you can just draw the line connecting those 2 points first, and then extend it like that. You need to extend it throughout the graph paper, just like that. And you'll get your third graph, C. So here in this example, we just review the fundamental equation of a straight line in the form y equal to mx plus b. Always remember, in y equal to mx plus b, m is the slope and b is the y-intercept. And if the slope are positive, like in A and B, the line will go up when you move from left to right. And if the slope is negative, like in C, when you go from left to right, you'll see that the line will go down. Do you have any question in this example? Please unmute yourself. No question on that? Okay. We'll move on to next example, and that's a very important example. And this is a little longer than the other one also. Let's first read what is given here. You can see managers of an outdoor coffee stand in Coast City are examining the relationship between the hot coffee cells. So they are looking at the relationship between the hot coffee cells and daily temperature, hoping to be able to predict a day's total coffee cell for maximum temperature of the day. And the bivariate data, when I say bivariate data, that is the data with X and Y are 2 variables. Okay, for the coffee cells, so coffee cells amount in dollar is here, and the temperature in degree along the X, which is here, these are the X values. Okay, and the maximum temperature X in Fahrenheit for The 15 randomly selected days during the past year are listed here. So this is the data given to you. And then there are several parts on this one. You can see there are several parts. So first, the question is the scattered plot shown a correct display of the data? Here is the scattered plot. You are not asked to draw the scattered plot. Instead, you have to examine this scattered plot. Is this scattered plot a correct scattered plot? What I'm going to do is I'm going to show you how we can create this scattered plot along with that line of best fit using the calculator. And then we are going to compare those two to see whether this is correct or not. So let me stop sharing this screen and share the calculator. So one more time, let me quickly show you what we have done here. See, in order to make the scatter plot, as I mentioned before, you go to edit, you put the data values, then we go to stat, calculate, and the number 4. And here we stored our equation in y1. Okay, after we stored the equation in y1, we calculate, we saw the value of r, it is negative 0.6. Now we are going to create the scatter plot. So for that, we press second, and then this plot or y, and we'll go to number 1. I'm just repeating the process for you. Make sure this is on. The scatter plot is selected. X values in list 1, Y values in list 2. Then graph it. So that is the line of best fit. The points are pretty close to the line, but not very tightly. So negative 0.6 makes sense. So this is what we get from the calculator. Now I'm going to show you the previous screen. Can you see the screen now? Yes or no?
Yes.
Okay. So what do you think? Is this scattered plot same as what we got in the calculator?
Yes.
Yes. So the answer to the first part is yes. Yes, this is the scatter plot for the data. Plot for the given data. Okay, now let me share back that calculator one more time. We stored the line of best fit here in Y. So if you go to Y and then look at this one, see in Y1, this is the equation of the line of best fit. So the equation of line of best fit, when we write that as y hat equal to negative 10.1533x. You may write this down, 1533x plus 2492.5549. That is the line of best fit from the calculator. Make sure you write that down. I write that over here. So the equation of this one is y hat equal to negative 10.1533 negative, because you can see as you go from left to right, the graph is going down or the line is going down. So negative slope makes sense. And then the y-intercept is 2492. Now, let's see what is asked in the other part of this problem. The same problem for the example on the previous slide, answer the following question. Now, in this one, the first part here, using TI-84 calculator, find the equation of line of best fit. We already got that. We just have to write that equation. If you check your notes, you wrote y hat equal to negative 10.1533x plus 2492.5549. Okay, that is the equation of the line of best fit. Now, using the information above, fill in the blank for each of the following. So here we need to fill this blank. For the data, the temperature value that are less than mean of the temperature or mean of X values, okay, tend to paired with the coffee sale values that are blank, the mean of the coffee sale values. Okay, it's talking about the mean. So what we are going to do is we are going to look at the calculator and we are going to find the mean of X and mean of Y. Now we'll go to stat, and then we are going to go to calculate because we want the mean. Calculate, and this is the two variable stat. You have the X value and Y value. So we are going to select 2. Okay, X is in list 1, Y is in list 2, which is good. And then if you go here and calculate, you'll see the mean for the X. Look at that. Mean for the X is 59.9933. So this is approximately 60. That is your X mean. And Y mean is here, which is approximately 1883.4. So that's your Y mean. So we are going to use this information now. Make sure you write them down. X mean is 59.99, which can be written as 60 approximately. And then the Y mean is approximately 1883. Write those two values. We are going to use those two values now. Okay, we'll go back to the line of best fit here. And here we are going to level that point. So the mean for X is 60, which is this one. So if you go all the way up here, the mean lies on the line of best fit. So this value is your mean. Hold on. So this point here is the mean of X comma mean of Y. It is mean of X comma mean of Y. You got that. It is 60 comma 1833. That is the value. So if you come down from here, you'll get the mean of X, which is 60, this value here. And if you come on this side, you'll get the mean of Y. You'll get the mean of Y, which is 1800. You can see there. Little bit above 1800. So 1833. That's 1800, little bit above that. Now, if you look at the question here, the question says for the data, the temperature value that are less than mean of the temperature. So mean of the temperature is here. When we say less than that, we are talking about these values. Okay, temperature values less than 60. So for the temperature values less than 60, we have to see for these data, temperature values that are less than the mean of the temperature value tend to be paired with coffee cell values that are blank the mean of the cell's value. So here we are looking for less than. So is this less or more? That's what we want to see. So if you'll check here, for these values, you can see if the temperature is smaller, right? If the temperature is smaller than mean, the coffee cell value is more. These points over here, in this region, the coffee cell values are above this value, above the average. So it is more than average. Okay, the cells values, these points, most of the points are above this line, which is more than. They are on this range. So the answer for the first part will be more. More the mean of the coffee cell values. Does that make sense? Please unmute yourself.
Yeah.
Okay, great. Now, let's look at the second part. The second part is talking about the slope. According to the regression equation, for an increase of 1 degree in temperature, the corresponding dash of $10.15 in coffee cell value. Let's go back to that equation again. If you look at the slope of this line, you know that slope is change in Y over change in X. And the slope is approximately negative 10.15 if I want to write up to 2 decimal places, negative 10.15. Now, if delta X is equal to 1, because the question says, according to the regression equation, for an increase of 1 degree in temperature. So when we say increase, this is plus 1. If delta X is plus 1, then what happens? Let's see. If you plug in plus 1 here, it will be delta Y divided by plus 1, which is simply delta Y, that is change in temperature, is negative 10.15. So meaning of that is, if the change in temperature, see delta X, if the change in temperature is plus 1, if the temperature increases by plus 1, then this one, the coffee sales value will decrease, because if it is warm, people drink less coffee. That is the meaning of that. So if delta X increases by 1, if the temperature increases by 1, okay, the sales value decreases by $10.15. So this one will be decreases by $10.15. That is the meaning of that. So this is actually the interpretation of the slope. Any question on that, part B? Yes, no? You can unmute yourself.
No.
Okay. So this is the interpretation that was looking at the trend. Now in C, from the regression equation, this is our regression equation, our line of best fit. What is the predicted coffee sale value in dollar when the temperature is 82.4? Meaning of that is, when the value of this X is 82.4, what is your Y hat? So what we are going to do is, we are going to plug in 82.4 into this equation. So Y hat is equal to, you have negative 10.1533. Here we are going to plug in 82.4 in place of this X. Okay, then plus, we have 2492.5549. So this is equal to, so what we are going to do is, we are going to type this in the calculator. You can also type that in your calculator and check it. Make sure you plug in and check. I got 1655.923. But here we are asked to round our answer to 1 decimal place. So if you round this to 1 decimal place, this is 16. You can see here you have 5, 5, then 9. So when you round it, it will go to a bigger number. So it will be 1656, 1656.0, because it is up to 1 decimal place. Okay, so we plug in the value, we got the result. Any question in C, what we did? Please unmute yourself when you're talking.
No.
Okay, now look at D. D is similar to C. So what I'm going to do is, I'm going to give you few seconds to work on D. Please work on D and find the result. I'll get back to you in about a minute. Please work on that. Okay, I hope you work on that. What did you get? Unmute yourself. I got this value, 1916.8626. And when you round it to 1 decimal place, it should be 1916.7. Is that what you got?
Hello.
Yes, 1916.7. Okay. So this is the
Shouldn't it
end.
be 0.9?
0.9. Hold on. I got, let me type it again. Please type it in your calculator again. Let's find it out. Negative 10.1533 times 56.7. Then we have plus 2492. I'm typing it again. 0.5549. And I got, oh, there is something error. Please wait. Something is not working. 10.1.
You
5.
rounded down, not up. So it
Yeah.
would be 0.9, not 0.7.
Right.
Oh, 0.9. Got it. I understand what you're saying. You are brilliant. Thank you.
Yeah.
That's right. That is right. How to put that point? Okay, I'll put it there. Does that look good? I think so, right? Okay, so this is the last example for today. I'm going to end it right here.